Why today might be slightly shorter than usual. Get ready for a mind-boggling revelation. Today, our planet Earth is spinning a little faster than usual, and it's causing quite a stir. Scientists have predicted that this day will be slightly shorter than the standard 24-hour cycle. And it's all thanks to the intricate dance of our spinning globe. The International Earth Rotation and Reference Systems Service, a group of experts who monitor Earth's rotation, has forecasted that July 22nd might be a millisecond shorter than expected. But here's where it gets controversial. This isn't the first time Earth has sped up its spin. In fact, variations in Earth's rotation are quite common, and scientists have been tracking these changes for centuries. Dennis McCarthy, a timekeeping expert and author, explains that the speed of Earth's rotation is influenced by a myriad of factors. From the gravitational pull of the moon to the movements of our planet's liquid core, these forces can cause our days to vary in length. And it's not just a theoretical concept. Researchers have been collecting data on Earth's rotation for thousands of years, thanks to ancient observations of solar eclipses in China. These days, scientists use advanced tools like radio telescopes pointed at distant quasars and GPS systems to track Earth's spin. All this data is analyzed by organizations like the International Earth Rotation and Reference Systems Service, which forecasts day lengths. But why does it matter if our days are a fraction of a second shorter or longer? Well, it turns out that understanding and predicting Earth's rotation is crucial for a wide range of applications. From launching missiles to navigating the seas and even high-tech farming, precise knowledge of Earth's spin is essential. As Nick Stamatikos, head of the Earth Orientation Department at the U.S. Naval Observatory puts it, the Earth's moving pretty fast, so any little variations will accumulate and it's an issue. And this is the part most people miss. Climate change is also playing a role in altering Earth's rotation. As ice melts at the poles due to rising temperature, water is redistributed towards the equator, slowing down our planet's spin. Some researchers have even calculated that, in a worst-case scenario, climate change could make humans the dominant driver of changes to day length, surpassing the moon's gravitational influence. So while today's slightly shorter day might seem like a quirky anomaly, it's a reminder of the complex forces shaping our planet. And it raises an intriguing question. As our climate continues to change, what other surprises might Earth have in store for us? Feel free to share your thoughts and opinions in the comments below. Earth's second shortest day ever. July 22nd, 2025. Why Earth is spinning faster. Imagine the Earth spinning so fast that its day actually gets shorter. By mere milliseconds, yes, but shorter nonetheless. Tuesday, July 22nd, 2025 is set to be the second shortest day of the year, and this surprising fact stems from the planet completing its rotation slightly quicker than the usual 24 hours. But here's where it gets really intriguing. Although the difference is only about 1.34 milliseconds, it reveals a subtle tug-of-war in our cosmic environment that you might not have thought about before. Normally, when we think of the shortest day of the year, most people point to the winter solstice, December 21st or 22nd in the northern hemisphere, or July 21st or 22nd down south. Those dates are famous because the tilt of the Earth means the least amount of daylight. But here's the key detail that many miss. That shortest day refers to the number of daylight hours, not the total length of the day itself, which is the time it takes Earth to spin once on its axis. On July 22nd, it's the whole length of the day, the actual rotation of the Earth, that shrinks ever so slightly. So why does this happen? Thanks to the dance between Earth and its natural satellite, the Moon, there's a gravitational pull constantly tugging at our planet. This interaction causes small changes in the speed of our planet's spin. According to experts at the Lunar and Planetary Institute, these gravitational fluctuations make Earth's spin a bit faster on some days, shaving off milliseconds from the total duration of a full rotation. This isn't an isolated case. Earth has been breaking its own rotation speed records quite often lately. For instance, just on July 5th, 2024, the planet recorded its fastest day ever, spinning 1.66 milliseconds quicker than the usual 24 hours. This year, July 10th clocked in as the shortest day, with Earth whirling 1.36 milliseconds faster than normal. And upcoming August 5th is expected to be the third fastest day, shortening by about 1.25 milliseconds. To put this into perspective, Earth's rotation typically takes about 86,400 seconds, but this number can fluctuate by a few milliseconds. Before 2020, the planet's shortest recorded day was only 1.05 milliseconds shorter than normal. That recent acceleration is quite notable. And here's a thought-provoking twist that scientists are grappling with. If Earth keeps spinning faster, we might soon have to introduce a negative leap second. In other words, subtract a second from our atomic clocks to keep them aligned with Earth's actual rotation. Since the 1970s, leap seconds have only been positive, meaning milliseconds were occasionally added to clocks. But the possibility of a negative leap second adds a new layer of complexity to how we measure time. And it's causing experts at institutions like the International Earth Rotation and Reference System Service to think hard about our timekeeping future. Let's travel back billions of years. When Earth first formed, about 4.5 billion years ago, it was spinning incredibly fast. A full day might have only lasted 3 to 6 hours. Over geological time, this day lengthened considerably. During the mid-Proterozoic period, roughly between 2.5 billion and 543 million years ago, each day stretched to about 19 hours, according to a recent scientific study published in Nature Geoscience. Since then, Earth's spin has gradually slowed to the comfortable 24 hours we know today, largely because of the moon's gravitational pull, which steals some of the rotational energy and creates tidal friction, acting like a cosmic brake. But here's a curveball that might surprise you. Climate change is now playing a role in how long our days last. As polar ice melts and redistributes the planet's mass through rising sea levels, it actually affects Earth's rotation speed, causing days to become slightly longer. This phenomenon was highlighted in a study published in the prestigious Proceedings of the National Academy of Sciences. So, human activity through climate change is indirectly influencing the very rhythm of our planet's spin. With all this in mind, isn't it fascinating how the length of a day, a concept we think of as fixed, can actually shift due to forces both ancient and modern? But here's a question to ponder. As we edge closer to a potential negative leap second, should we question our reliance on atomic timekeeping? Or do these tiny changes in Earth's spin matter more for scientists than the average person? What do you think about the subtle influence of the moon and climate change on our daily lives? Share your thoughts and join the conversation, because when it comes to time and Earth's rotation, there's more to the story than meets the eye. Earth's spin speeding up. How it's affecting our time. Our planet is spinning faster than ever, and it's causing a timekeeping crisis that could disrupt everything from your smartphone to global financial systems. Imagine a world where we might need to subtract a second from our clocks, a move so unprecedented it's never been done before. But here's where it gets controversial. Could this be the next Y2K level problem, or are we overreacting? Let's dive in. This summer, Earth has been breaking records for the shortest days ever measured. On July 10th, the planet completed its rotation 1.36 milliseconds faster than the standard 24 hours. According to data compiled by timeanddate.com from the International Earth Rotation and Reference Systems Service and the U.S. Naval Observatory. And it's not stopping there. July 22nd and August 5th are predicted to shave off 1.34 and 1.25 milliseconds, respectively. While these fractions of a second seem insignificant, they're enough to send scientists and timekeepers into a frenzy. Here's the deal. Earth's rotation isn't perfectly consistent. It's influenced by factors like the moon's gravitational pull, seasonal atmospheric changes, and even the movement of its liquid core. These variations usually result in days that are slightly longer or shorter than 86,400 seconds. But they rarely affect our daily lives. So why the sudden concern? Because these tiny discrepancies can accumulate over time, posing challenges for technologies that rely on precise timekeeping, such as computers, satellites, and telecommunications. Enter atomic clocks, the unsung heroes of timekeeping since 1955. These devices measure time by counting the oscillations of atoms in a vacuum chamber, providing the most accurate time possible. This atomic time, known as Coordinated Universal Time, UTC, is the global standard used by everything from your phone to GPS satellites. But here's the kicker. UTC occasionally needs adjustments to stay in sync with Earth's rotation. Since 1972, we've added 27 leap seconds to UTC, but Earth's accelerating spin has slowed the need for these additions. In fact, no leap seconds have been added since 2016. And this is the part most people miss. In 2022, the General Conference on Weights and Measures voted to phase out leap seconds entirely by 2035. But if Earth keeps speeding up, we might face an even stranger scenario, a negative leap second, where a second is removed from UTC. The probability of this happening by 2035 is about 40%, says Duncan Agnew, a geophysicist at the University of California, San Diego. Talk about a plot twist. So what's causing this sudden acceleration? The moon and tides play a big role, slowing Earth's spin when the moon is over the equator, and speeding it up when it's at higher or lower altitudes. Additionally, during summer, Earth naturally spins faster due to seasonal atmospheric changes. But there's a surprising wildcard. Climate change. Melting ice in Antarctica and Greenland is redistributing mass across the planet, slowing its rotation, much like a skater spinning slower with arms tucked in. Without global warming, Agnew notes, we'd already be dealing with a negative leap second. But here's the controversy. While some experts compare this to the Y2K bug, others argue it's a manageable issue. After all, leap seconds have caused problems for decades, and a negative leap second has never been tested. Judah Levine, a physicist at the National Institute of Standards and Technology, warns that the consequences could be severe for critical systems like telecommunications and electric grids. Yet, others believe we have time to adapt, especially since long-term predictions about Earth's rotation remain uncertain. So what do you think? Is this a ticking time bomb, or just another technical hurdle we'll overcome? Let us know in the comments. And stay tuned as scientists race to keep our clocks in sync with a planet that refuses to slow down.